Hi everyone, welcome to Mathworld. This video is to discuss Cambridge International AS and A-Level Mathematics Paper 6, which is the Probability and Statistics 2 for October-November 2023, and the code is 9709/61. Just for your information, the contents of this paper is same as 9709/63. Okay, so these two variants, the paper will be the same. Okay, so let's move on to question number 1. Now for question number 1, a random variable x has a distribution which is normally distributed with mean 410 and also variance 400. Find the probability that the mean of the sample of the random sample of 36 values of x is less than 405. So now to get the probability of the mean of the x, right, that means now we need to get the distribution of the mean, which is the x bar. So initially your x is normally distributed with mean, mu, 410 and 400. Alright, just for your information, when x is normally distributed with mean mu, variance sigma squared, then the x bar will be normally distributed with mean mu and variance now becomes sigma squared over n. Okay, so our n is 36. Therefore, my distribution becomes 410 followed by 400 divided by 36. Okay, and now we need to calculate the probability that the x bar mean, okay, is less than 405. So then from here, we need to standardize the normal random variable. So when we need to standardize normal random variable, basically if it is the x, it will be z equals to x bar minus mu over sigma. Okay, but right now we are solving for x bar. Therefore, it will be z equals to x bar minus mu over square root of sigma squared over n. Okay, means basically we are taking square root of the variance, right? So from here, I will be getting PZ less than 405 minus 410 divided by square root of 400 over 36. This will be my working. Okay, then from here, you will be getting PZ less than negative 1.5. So when PZ less than negative 1.5, now we need to sketch a graph. Draw a symmetrical graph at origin. When less than negative 1.5, so now I mark the line. I mark the line negative 1.5 and the region is towards left side because it's less than. So then from here, we will just flip the graph to the right side. Okay, the region to the right side. So here is going to be 1.5. Now the blue region is same as the red region right now. So it will be total probabilities 1 minus PZ less than 1.5. That will be the red region. So here I will write 1 minus PZ less than 1.5. Okay, then now this probability can be found using the table in the formula list. Then you will be getting 0.9332. Okay, so once you have solved this operation, it will be 0.0668. So that's the solution for question number 1. Okay, now next question number 2. In a survey of 300 randomly chosen adults in Rickton, 134 said that they exercise regularly. This information was used to calculate an alpha % confidence interval for the proportion of adults in Rickton who exercise regularly. The upper bound of the confidence interval was found to be 0.487, correct to 3 significant figures. Now find the value of alpha correct to the nearest integer. So we know that, right, alpha % confidence interval of proportion. The formula is basically p hat. Alright, so it's basically p hat plus minus z square root p hat q hat over n. Alright, it will be z alpha over 2. So from here, my p hat is 134 over 300. So here I will write 134 over 300 Now, for this confidence interval, we will be getting the upper bound and lower bound. So the upper bound is found when we refer to the plus. Therefore, now is given upper bound of the confidence interval. So I will be using plus. Okay, so the z value we do not know because it depends on your alpha value. Then square root of the p hat is 134 over 300. Now, for your information, the p hat is 134 over 300. Okay, then the q hat is 1 minus p hat. So when you calculate this value, it should be 166 over 300. So that's the p hat's value. That's the q hat's value. So here I will write 166 over 300. Then divided by 300. Okay, so and this is going to give you the upper bound of 0.487. Alright, so now to get the z value, z alpha over 2, firstly, I will move this 134 over 300 to the right side, becomes minus. Then this whole square root will be moved to the other side, becomes divide. Okay, or you can just switch the position, the numerator and denominator. Then here I will be getting 0.487 minus 134 over 300. Okay, instead of multiplication, now I change to division. So divide by the whole square root. So here 134 over 300 times 166 over 300, then over 300. Okay, so when you calculate this value, it will be 1.4052. Alright, so now once you get the z value is 1.4052, that means when I refer to the graph, right, here is 1.4052 because the middle value is 0. Now, you read the value from the table, Pz less than 1.4052, it will be 0.9199. This value is from table. Okay, so which means the 0.9199 is the region towards left side. So now I need to find out what is this. Okay, because I need to find the percentage. So from here, I will be getting Pz more than 1.4052 is going to be 1 minus 0.9199, which is 0.0801, which means now my question mark is basically, right, is basically 0.0801. Alright, then from here, how do I apply to get the alpha value? So we know that basically when you form the confidence interval, it's basically these two regions. It's basically bounded by these two lines. Okay, so from here I know that they are symmetrical, which means the region on this side, on the left hand side, is also same value 0.0801, which is same value as the right side. Okay, then from here I just need to find out what is the middle value. Alright, so from here I will say alpha percentage, it will be total is 1. I minus these two regions. Okay, that will be the middle region. So it will be 1 minus 2 of 0.0801. And then here, since we need to find percentage, so I times 100%. Okay, then from here, I will be getting 83.98%. And now when you refer to the question, it's mentioned here to the nearest integer. Okay, so now I got to round up, then it will be 84%. So in other words, my alpha is basically 84. Okay, so that's the solution of this question. Okay, now next question number 3. A website owner finds that on average his website receives 0.3 hits per minute. He believes that the number of hits per minute follows a Poisson distribution because it's how many hits per minute, there is a time interval. Now A, assume that the owner is correct. First part, find the probability that there will be at least 4 hits during a 10-minute period. So this 0.3 hits is per minute for 1 minute. Now we are considering 10 minutes. Therefore now I need to calculate what is the number of hits during the 10 minutes period, which is 0.3 multiplied with 10. Then I will be getting 3 hits per 10 minutes. Okay, and now you need to calculate at least 4 hits. So which means now our X is Poisson distributed with mean 3. And now you need to count probability that X at least 4. So greater than equals to 4. So when greater equals to 4, it will be 1 minus all previous. So which means 0 to 3. Okay, then from here I will get, now by using the formula, okay, but X is Poisson distributed with mean lambda or mu, right? Then the probability is basically E minus mu to the power of X over X factorial. So you should understand that this E minus mu is a constant, okay, because the variable is X. So which means from here, I will factorize E negative 3 because my 3 is a mu now. So it will be 3 power 0 over 0 factorial, that is 1. Then plus 3 degree 1 over 1 factorial is still 3. Then plus 3 squared over 2 factorial. Then plus 3 cubed over 3 factorial. Okay, then from here, you will be getting 0.353. So that's the probability correct to 3 significant figures. Now part 2, use a suitable approximating distribution to find the probability that there will be fewer than 40 hits during a 3-hour period. So go back to the original question. Per minute is 0.3 hits, right? So we know that 1 hour, right, has 60 minutes. Okay, per minute it will be 0.3. So I have to times 0.3. Then from here you will be getting 54. Okay, so from here I will say that my Y now is Poisson distributed because my Y is per 3-hour period. It will be Poisson distributed. Okay, or I will say that now it will not be Poisson distributed because this value is greater than is a huge number. Therefore, in the question you are given approximating distribution. Okay, so because of that, now our Y, or probably I will just define first. Okay, my X initially Poisson. I don't want to use X because just now I will use X. So let's say hit Poisson distributed with 0.3. Okay, this is per minute. So now I will approximate to Y, which is normally distributed with mean for 54 and variance 54. Okay, because this is our new mu. So now you need to calculate the number of hits is less than 40. So PH less than 40. So now when you look at this distribution, this Poisson is discrete distribution, then the normal is continuous distribution, right? So from discrete change to continuous, that means you need to consider the correction, the continuity correction, which means now when I draw the number line to show 40 here, okay, H is less than 40. So less than 40 means we will accept 39, 38, and so on. Okay, and then for the continuity correction, you have to plus or minus 0.5 from the given value, which is from 40. So when I plus 0.5 from 40, it will be 40.5. When I minus 0.5 from 40, it will be 39.5. And by looking at the operation here, the inequality here, which is less than, that means I have to accept either less than 39.5 or less than 40.5. So obviously, to include these two ticks, the blue ticks, I have to accept 39.5. Okay, which means now I will write here, which is Py less than 39.5. So when Py less than 39.5, that means now we standardize it. So again, when we standardize, right, when x is normally distributed with mean, mu, variance, sigma squared, when you standardize it, it will be x minus mu over sigma, which means now here I will get z less than 39.5 minus mu, mu is 54, over square root of 54. Okay, then from here I will be getting z less than negative 1.973. Okay, so once you obtain this z value, sketch a graph. Middle value is 0. Now the negative 1.973 is on the left hand side and the region is less than. That means the region is towards the left side. Now this region is not available in the table, therefore you flip it or you reflect it to the right side. It will be same as the region which is greater than the region of z greater than 1.973, which means to get this orange region, it will be 1 minus Pz less than 1.973. Okay, then from here I will get it is 1 minus Pz less than 1.973. Then now from the table, you will be getting 0.9758. And at last, you will be getting 0.0242. So that's the probability of this question. Okay, next part of the question. A friend agrees that the website receives on average 0.3 hits per minute. However, she notices that the number of hits during the daytime, means from 9 a.m. to 9 p.m., is usually about twice the number of hits during the night time. Now, B, first part, explain why this fact contradicts the owner's belief that the number of hits per minute follows a Poisson distribution. Okay, so the reason is the number of hits per minute is not constant, because here initially 0.3 hits per minute, then it believes that daytime will be double of the hits of the night time. Okay, so the reason is the number of hits per minute is not constant. Alright, so that's the reason of this question. Okay, now part 2. Specify separate Poisson distributions that might be suitable models for the number of hits during the daytime and during the night time. Okay, so from here, from the previous question, we know that the daytime number of hits during the daytime is twice the number of hits during the night time. So now here I will write number of hits during daytime equals to double. Okay, double number of hits during night time. So now, let's P be the number of hits during night time. Alright, so for the daytime, it is 2P because it's double of the hits during the night time. Then you plus the number of hits during the night time, it will be P. It will be 2 of 0.3 because it's mentioned that it will be 0.3. So now we have two distributions. This is why 2 times 0.3. Then from here, I will be getting 3P equals to 0.6. That means my P is basically 0.6 divided by 3, which is 0.2. Okay, so therefore, the number of hits during night time okay, let's say n, it will be Poisson distributed with 0.2 hits per minute. And then the number of hits during daytime, let's say denoted by D, it will be double of the number of hits during night time. It will be 0.4. Okay, so this will be the distributions of two different timing. This distribution for the hits during two different timing. Okay, now next question number 4. The masses in kilograms of chemicals A and B produced per day by a factory are modeled by independent random variables x and y respectively, where this is the x and this is the distribution of y. The income, okay, the income generated by the chemicals is $2.50 per kilogram for A and $3.25 per kilogram for B. Now A, find the mean and variance of the daily income generated by chemical A. Okay, so now from here, I will write my income, let's say income of chemical A is IA. Okay, IA, that will be 2.5x because the x is basically the mass of the chemical A. Okay, then the income, okay, here I should write chemical A. So income, okay, the B no need to write. Alright, because the question is asking for A only. So from here, what I need to do here is I need to find the E. So EIA is basically E 2.5x, which is 2.5 expected x. So the x is here, right? This is a distribution, which means this is the expected x. Expected is basically the mean, and then this is the variance. Right, then from here I will get 2.5 times 10.3, and then you will be getting 25.75. Now for the variance A, variance of income A, it will be variance of 2.5x. So from the loss of variance, it will be 2.5 squared variance x. Then now the variance x is given, which is 5.76. So here I will be getting 2.5 squared times 5.76. Then you will be getting 36. Okay, so that's the solution of this part. Now B, find the probability that on a randomly chosen day, the income generated by the chemical A is greater than the income generated by chemical B. Okay, so now I let income generated by chemical B be IB. Okay, IB. then whereby the IB is 3.25. Okay, it's here 3.25 Y, because the Y is the mass of the chemical B. Okay, so 3.25 B. Sorry, 3.25 Y. Okay, so now you need to calculate P income A is greater than income B. Then from here, it is the same as P income A minus income B is greater than 0. In other words, I need to find the expected value for IA minus IB and also variance for IA or minus IB. So since we have counted the IA in the previous part, so now I need to count EIB. Okay, so EIB, it will be 3.25 EY. So expected value of Y is given, which is 11.4. So I will just direct replace 3.25 times 11.4. And this is going to be 37.05. Then now my variance of IB, it will be 3.25 squared variance of Y. Okay, then this is going to be 3.25 squared times variance of Y is 9.61. Then this is going to be 101.5056. Okay, so now I need to calculate the expected IA minus IB. So this is expected IA minus expected IB. Okay, expected value for IA minus expected value for IB. So EIA we have found just now the mean, which is 25.75. So here I will write 25.75 minus EIB is 37.05. Then you will be getting minus 11.3. Okay, and same goes to the variance IA minus IB. Then this is going to be variance IA plus variance IB. Right, so variance IA is 36. So here I'm getting 36 plus 101.5056. And then this is going to be 137.5056. Alright, so now I refer to these two values to standardize the variables. Okay, so now when I standardize the variables, it will be equals to P Z more than 0 minus the mean. Mean now is negative 11.3 over variance. So the variance is 137.5056. Then from here, it's going to be Z more than 0.964. Okay, so when Z more than 0.964, let's say I refer to the graph. This is 0.964 and the region is towards right side. So then from here, I know that it's going to be total regions minus, right, total regions minus PZ less than 0.964. So here I will write equals to 1 minus PZ less than 0.964. And now read the value PZ less than 0.964 from the formula list, right? It will be 0.8325. Then now when you minus, it will be 0.1675. And at last, round up the answer correct to 3 significant figures, then you will be getting 0.168. So that's the solution of this question. Okay, let's move on to next question. Next question, number 5. In the past, the number of enquiries per minute at a customer service desk has been modeled by a random variable with distribution Poisson 0.31. Following a change in the position of the desk, it is expected the mean number of enquiries per minute will increase. Now, in order to test whether this is the case, the total number of enquiries during the randomly chosen 5-minute period. Okay, this is per minute, right? This 0.31 is per minute. Now you consider 5 minutes. You should assume a Poisson model is still appropriate. Now, given that the total number of enquiries is 5, carry out a test at the 2.5% significant level. So this is the hypothesis testing regarding the Poisson distribution. Okay, so now first of all, I have to recalculate what is my mu. My mu is 0.31 times 5 because the 0.31 is for 1 minute. So now we consider 5 minutes. So it will be 1.55. Right? You can write mu or you can write lambda. So same for both. So here I will write h naught. My lambda will be 1.55. But then now you believe that it will increase. Therefore, your h1 lambda will greater than 1.55. Okay, and then this is the alpha value. So alpha is 2.5%. That means that is 0.025. Now, for the Poisson distribution, your rejection criteria will be reject h naught if probability that x greater equals to 5. Why 5? Because the total enquiries is 5. Why greater equals to? It because of the h1, because here greater. Therefore, we follow the sign greater. But we have to consider the 5 as well. So here less than the alpha value. Okay, so now we calculate the probability of x at least 5. So at least 5 means it will be 5 onwards. Then I will just use 1 minus all previous probabilities. So it will be probability of px equals to 0 until 4. Right? So now since this is Poisson distributed, so if you still remember, your x is PO, let's say lambda, then your px equals to x. It will be e minus lambda x over x factorial. Okay, so now I will factorize the exponential. So it will be e negative 1.55. Then the first probability is 1. Second probability is 1.55 here after you factorize the exponential function. So here 1.55 squared over 2 factorial plus 1.55 cubed over 3 factorial plus 1.55 degree 4 over 4 factorial. Okay, then from here you will be getting 1 minus, let's say I calculate the value, 0.978972. That is the probability of the brackets. Right, so now that it will be 0.021028, and now I round up to 3 significant figures. That will be 0.0210, which is less than alpha. Okay, because your alpha is 0.025. Right, or probably I will just write less than 0.025. So when it is less than, that means now, okay, here less, that means our conclusion is reject h naught. Alright, so here I will just write since px greater equals to 5 is less than alpha, so decision is reject h naught. So when reject h naught, what is the conclusion? Conclusion means that, okay, we rejected the h naught, right? It's like we do not accept this. Okay, so reject h naught. Therefore, it will be, it's like we accept this, right? So there will be sufficient evidence to conclude it has increased, right? So there is sufficient evidence at alpha equals to 0.025 to conclude that the mean number of enquiries per minute has increased, right? The mean number of enquiries has increased. Okay, so that is the conclusion for this hypothesis testing, because we have rejected the H0. Okay, now next question, number 6. A continuous random variable x takes values from 0 to 6 only and has a probability distribution that is symmetrical. So two values a and b of x are such that probability that x between a and b is p, and the probability that x between b and 3 is 13 over 10p, where p is a positive constant. Show that the p is less than equals to 5 over 23. Okay, so from here, I will just simply sketch a graph first, because it's mentioned symmetrical and the value just takes 0 to 6. Okay, let's say just an example. Okay, let's say this is the graph, symmetrical. That means here is 0, this is 6. Right? So, which means now, this is 3. Symmetrical. Okay, so now, x between a and b is p. So, let's say here is a. This is a, this is b. So, the probability is p here. And then b to 3 is 13. That means the other side. This is 13 over 10p. Okay, so now we need to show that p is less equals to 5 over 23. So from here I will say that, because we have no idea where is the a, then I will say that, right, p x less equals to 3, it will be less equals to half. Okay, here it will be half. So I'm not sure whether what is the value from 0 to a. So, but then I will say that p plus 13 over 10p will be less equals to half. So when you calculate this, it will be 23 over 10p less equals to half. Therefore, your p less equals to half times 10 over 23. Therefore, right, so your p will be less equals to 5 over 23. So this is how we show the probability. Okay, the half and 2, the 10 and half can be cancelled off. Can be simplified. So that's all for this solution. Okay, now find x between b and 6 minus a. Okay, so now in terms of p, let's say for example, you look at the table here, 6 minus 8. The a is this region, so which means probably I will say this is my 6 minus a, so that this width is a. Okay, and now you need to calculate b and 6 minus a is bounded by b and 6 minus a. Okay, so from here, I will say that now you need to find this probability. Okay, so in order to get this probability, it will be probability of x less than 6 minus a minus p x less than b. Right? So then from here, I will write p x between b and 6 minus a. It will be p x less than 6 minus a minus px less than b. Okay, how to get the probability of x less than 6 minus a? Okay, now let's look at here. 6 minus a means all this, so I need to know what is this region. Okay, so since it is symmetrical, which means, right, this region is same as here, is same as the left side. So this left side, we know that this is half, right? Px less than 3 is half because it's symmetrical. So which means this px between 0 and a is basically 0.5, which is half, minus p and 13 over 10p. That means this is going to be 2.3p, right? So minus p plus 13 over 10p. That means this is going to be 0.5 minus 2.3p. Okay, same goes to this part. This part will be 0.5 minus 2.3p. So here I will write it down here, right? Px less than a, or I will say that it's between 0 and a. It will be better. So between 0 and a, it will be 0.5 minus p plus 13 over 10p. That means this is going to be 0.5 minus 2.3p. Okay, it is same as probability that is between 6.6 minus a and 6. So 6 minus a and 6. That means this is right here. But then now we need x less than 6 minus a. X less than 6 minus a means total probabilities, which is here. You need to find this, right? I will say that this probability is same as 1 minus this part, right? So here I will write it is 1 minus p x between 6 minus a and 6. That is my first probability. And then minus px less than b. So px less than b is basically p with this, right? So it will be probability of x between 0 and a plus probability of x between a and b. Okay, so then from here I will write 1 minus, this probability is basically 0.5 minus 2.3p, and then I minus x between 0 and a is basically 0.5 minus 2.3p. Then plus x between a and b. So x between a and b is given in the question, which is p. Okay, then from here, when you open the bracket, the first one, 1 minus 0.5 is 0.5. Then the minus times minus, it will be plus. So here I will get plus 2.3p. Then minus, right? Bring the minus in. So it will be minus 0.5. Then this negative 2.3p plus 1p is negative 1.3p. Together with the minus, it will be plus 1.3p. Therefore, right, the 0.5 will be cancelled off. These two will be cancelled off. Then you will get 2.3p plus 1.3p. Therefore, the answer is going to be 3.6p. So that's your solution for the part B. Okay, now next. It is now given that the probability density function of x is f. whereby this is the function. Okay, given that b equals to 2 and p equals to 5 over 27, find the a. So now let's look at the previous part that involves b and also p. Okay, so involves b and also p. That means refer to probability of x between a and b is p. Okay, so now from first part or from a, probability that x between a and b is p. That means now I will get probability of x between a and 2 is 5 over 27. So now we have to use the integration to get the probability. So now integrate, right? 1 over 36. So since this is a constant, you can just factorize the constant. Then integrate the rest. 6x minus x squared dx. This is the probability. Then from a to 2, and it is 5 over 27. So now when you do integration, okay, so we need to plus 1 degree to the x. So here becomes 6x squared over 2 minus x cubed over 3. Then consider limits from a to 2. It will be 5 over 27. Alright, so from here, when we simplify, it will be 1 over 36 times 3x squared minus x cubed over 3. Limits from a to 2. Then equals to 5 over 27. Now replace the x by 2 first. So then now this 1 over 36 I will just times to the right side. Okay, or probably I just times the whole equation by 36. Then here I will be getting 3, replace the x by 2 minus 2 cubed over 3, then minus, replace the x by a. So I will get 3x squared minus a cubed over 3. Now for the right hand side, 5 over 27 times 36, you will be getting 20 over 3. Okay, then from here when you calculate, the first one is going to be 28 over 3. Okay, I will just calculate these two at the same time. Calculate these two at the same time, then you will be getting 28 over 3. Then the minus, you bring it into the brackets. So here I will be getting minus 3a squared plus a cubed over 3. That equals to 20 over 3. So the whole equation I will multiply by 3. Then it will be 28 minus 9a squared plus a cubed equals to 20. Okay, and now rearrange. So I'll get a cubed minus 9a squared. So the 20 will be moved to the left side. So 28 minus 20, it will be plus 8. So here plus 8 equals to 0. Now, the question is asking for a. Okay, and find the value only 1a. So therefore now to get the a, I need to solve this cubic equation. So to solve this cubic equation, alright, you can just let HA be the cubic equation. Then now use a trial and error method. H1 is 1 cubed minus 9 times 1 square plus 8. Then it will be 0. That means a minus 1 is a factor. Okay, and now I need to get the quadratic factor. So I will perform my long division or polynomial division on this side. It will be a cubed plus 9a squared. Now, this is your HA. There's no a, so I write 0a, then plus 8, divided by a minus 1. So to get a cubed from a, I need to times by a squared. So a squared times a cubed. A squared times minus 1, it will be minus a squared. Then minus. So first term, you get 0. Second term, 9a squared minus a squared is 10a squared. Okay, bring down the plus 0a. And now I need to multiply with plus 10a. It will be 10a squared minus 10a. And now again minus. So 10a. Oh, wait, let me check. Okay, 9a squared. Wait, okay, mistake is here. This is minus, right? This is minus, but I wrote plus, so it should be minus. Sorry on that. Okay, so because of a small mistake here, then we have to resolve. So here is going to be minus 9 plus 1, so minus 8. So I need to times by minus 8a. So here is going to be minus 8a, then plus 8a. So when you minus 0 minus 8, it will be minus 8a plus 8. Then from here, you multiply with minus 8. So you will be getting minus 8a plus 8. Okay, then from here, you will be getting a minus 1 times a squared minus 8a minus 8 equals to 0. Then for the quadratic equation, okay, so from here, I will get either a minus 1 be 0 or a squared minus 8a minus 8 equals to 0. Now, for your information, if let's say you are given ax squared plus bx plus c equals to 0, to find the x, it will be minus b plus minus square root of b squared minus 4ac over 2a. Okay, so now I have to use this formula to get the a. So now my a, instead of x in the formula, now becomes a. Alright, so it will be minus, my coefficient for a is minus 8 plus minus square root of the coefficient for a minus 8 squared minus 4. Coefficient for a squared is 1, then the constant is minus 8 over 2 times 1. Then from here, you will be getting 8 plus minus square root 96 divided by 2. And now you calculate the two values. It will be negative 0.899 and the other one is 8.90. Okay, so we have three values here. But then when you look at the question carefully, right, we know that the x is between 0 and 6. Okay, therefore the a cannot be, or probably I will say that the a is less than 2. Alright, it's between 0 and 6 and also less than 2. Therefore, I only get a equals to 1. So then you here just write given a is less than 0 and 6 and a basically is less than 0 and 2. Okay, basically like this. Alright, given 0 and 2. Okay, therefore, or hence, my a is going to be 1. So that's the solution of this question. Okay, now question number 7. A biologist wishes to test whether mean concentration, mu, in suitable units of a certain pollutant in a river is below the permitted level of 0.5. She measures the concentration X of the pollutant at 50 randomly chosen locations in the river. And you got these three values. Now A, carry out a test at the 5% sequence level of the null hypothesis mu is 0.5 against the alternative hypothesis mu is less than 0.5. Okay, so from here, firstly write down the H0, which is mu equals to 0.5. Then the H1, your mu is less than 0.5. Alpha value is 5%. So alpha is 0.05. Okay, so from here, right, I will just draw the graph. This is normally distributed. So we know that it is less than 0.5. Okay, therefore the region is on the left side. This is lower tail test. And here is 0.05. Here is 0. Now, to get the critical region, we need to reflect it to the positive side. That means here is 0.05 and the properties towards the left side will be 0.95. Now from the table, you will be getting 1.645 for the red line, but then our original line is a blue color. Therefore, it is negative 1.645. So now our rejection region is reject H naught if the Z is less than negative 1.645. Okay, so now you are given the summation x and summation x squared. We need to calculate the mean and variance. So then, now x bar is summation x over n. This is going to be the 23.0 over 50. Then you will be getting 0.46, and then the s is square root of 1 minus n minus 1, 1 over n minus 1 times by summation x squared minus square of summation x, then divided by n. So this is going to be square root of 1 over 49. Summation x squared is 13.02 minus summation x is 23.0 over 50. So then this is going to be 0.223150. Here I give more decimal places because this is just the working. So now I need to calculate what is my z. My z is x bar minus mu over s over square root n. Okay, so my x bar is 0.46. My mu is the value at the h naught. So at the h naught, the mu is 0.5 over 0.223150 divided by square root of 50. So this is going to be negative 1.27. Right, so negative 1.27 is basically outside the region. So our decision is do not reject H naught. Okay, so then here you write, since Z is greater than negative 1.645, do not reject H naught. So when do not reject H naught, okay, so means that we have to accept this. Or probably you can say that we don't have enough evidence, insufficient evidence to say that the mean concentration is below the permitted level, right? So here I will just write there is insufficient evidence at alpha is 0.05 to conclude that the mean concentration of the pollutant, okay, of the pollutant is less than 0.5. Okay, so that is the conclusion for this hypothesis testing. Okay, now next part. Later, a similar test is carried out at 5% significance level using another sample of size 50 and the same hypothesis as before. You should assume that standard deviation is unchanged. Now B, given that in fact the value of mu is 0.4, just now was 0.5. Find the probability of type 2 error. Okay, so now type 2 error, probability of type 2 error equals to probability of do not reject H naught given that H0 is false. Okay, so now I need to find out what is my Z value so that, or what is my X bar value so that we do not reject H0. Okay, I need to find what is the region for do not reject H0. So now I will write here. So Z equals to X bar minus mu over S over square root N. And then from the previous calculation, we know that, right, reject H0 if the Z is less than negative 1.645. So I need to find out what is the X bar to give you this Z value. So then I will replace my Z by negative 1.645. So here, negative 1.645 is X bar minus 0.5 over the S from the previous question, or from the previous part, which is this value, 0.223150 over square root of 50. Okay, then from here, my X bar is negative 1.645 multiplied with the denominator. After that, the minus 0.5 will move to the other side, so it becomes plus 0.5. Then from here, your X bar is going to be 0.4481. Okay, so now when you go back to the previous rejection criteria, when the Z less than negative 1.645, we reject H0. Okay, and the X bar that will gives you this negative 1.645 is 0.4481, and now we do not reject H0, which means your X bar must be greater than this value so that your Z will be greater than negative 1.645. Okay, that means here it's going to be X bar greater than 0.4481. And given that H0 is false, that means now your X bar is normally distributed with new mean, which is 0.4. Okay, and then the variance remain. So 0.223150 squared over 50. Right, so then from here I will get PZ more than, so you standardize it, 0.4481 minus 0.4 over, now remember this is variance, this is standard deviation, so I squared it to make it to variance. Okay, so here is going to be 0.22315, there's a 0 missing, over square root of 50. Then now here I will be getting PZ more than 1.524. Okay, when more than 1.524, I will just refer to the graph, the normal graph. Here is 1.524, and then the region is towards right side. So obviously to get this probability, it will be total regions minus PZ less than 1.524. So here I will be getting 1 minus PZ less than 1.524. Okay, then it is 1 minus, that probability is going to be 0.9362. And at last, you will be getting 0.0638. Okay, so that's all for this working. Right? Okay, so I have come to the end of the video. Thanks for watching. Please subscribe to the channel and like this video if you enjoy watching my videos. Thank you and see you. Bye.